No, don't yank it. Push down on that.
All right, submit the answers you have. We're going to get started going over this.
1, 3, 6, and 7.
Okay, I'm going to stop the poll in just a second. I'm going to go ahead and look through the slides, get us started with this. So here's our agenda. We're going to wrap up lesson 4, true to form, and then we're going to get, writing quadratic equations practice. So we're going to get some practice at the end of this lesson to get more comfortable with these different forms. But I need you to hear me very clearly. You need to know the 3 forms of a quadratic equation. And you need to be able to match them. And so we may need to use our notes. Now, one thing I will say is this. Personally, I think that this Desmos summary is pretty good. But I do think that the notes that we took in the book with the matching the equations to the graph and we talked about each feature, I think that those are a little bit cleaner even. So I might be looking at those pages to help me out. I think it's 73 to 75. That's just me. But use that to help you study, because what are we going to have at the beginning of class tomorrow?
Understanding check.
We have an understanding check. So we need to be aware of that. We need to be working efficiently today. As a quick note, we will have tutoring this afternoon. Tomorrow is usually when it is, but I have a meeting with coworkers. It was supposed to be this afternoon and got moved. So I will not be able to tutor after school tomorrow. I will be here. I'll go ahead and say I'll be here this afternoon and tomorrow morning, because that should help if you need to prepare for that understanding check. And so don't forget at all times, what is math?
Patterns and relationships.
Study of patterns and relationships, and there's a language involved with that. We got to be careful and intentional with our language. The better you understand the language, the easier it is to communicate about these things. And the people who talk the most, I can go ahead and tell you, they learn the most. Legitimately, those who talk the most, there's a handful who burst up to the top levels of the test, which yes, I did get the test in last night. I was up till 1 doing that and then got up at 4:40. It was rough. But I work out every morning before school. Yeah. So I got those tests in. I went through and I identified, no, you better not be looking at it right now. We got math to learn today. But you can go into Schoology and look. For the vast majority of us, you may not have blown it out of the water and made the 100 that I know we won, or we crushed and made an A. I did have several A's, but I had a whole lot of B's, and more importantly, I looked back at the understanding checks, and out of the 23 on each of the understanding checks, and it wasn't always the same, I want to say at least 19 of 23 improved on understanding check 1, and I think 18 of 23 improved from understanding check 2 to the test. So I need you to pay attention to that. It's not just about, hey, did I make an A? That growth is important. And so we want to pay attention to the fact that we grew and we learned. That's what I want you to remember when you come in and I ask you, or I greet you by name and I want you to respond with, I am capable. It's not necessarily that you're capable of making 100, but you are always capable of growing. And if you're always capable of growing, you can always improve. And I had some people that I did see on one understanding check, I think went from a 60-something to like literally a 95 or 98% on that understanding check. Like that kind of growth is possible. And I honor that and I reward that by replacing your previous understanding check grade with whatever corresponding grade you had on the test. And so be aware of that. But today we're focusing on the forms of quadratic equations. Now I need you to be careful. I need you to remember there are three types of functions we're studying. What are those 3 types of functions?
Vertex, fact.
Linear, quadratic, and exponential. Remember, the types of functions are linear, exponential, and quadratic. They each have a different rate of change. They each have a different shape on the graph. They each have different equations. All right? But when we specifically focus on quadratic, what are the forms of quadratic equations? Vertex. Standard and factored form. You got to keep that, be careful about that. That's one thing I noticed a lot of students forgot, is that there's a difference between the types of functions, linear, exponential, and quadratic, and the forms of quadratic equations. You've got to study those two different things. And you got to make sure you keep those straight. But we're focusing on the forms of quadratic equations and identifying the features of a parabola based on the form of quadratic equation. So we did all of this where we taped quadratic equations or glued them to the graphs and then glued the graphs to the correct graphic organizers and filled in information there. Again, there's a lot of equations on those graphic organizers. It is more effective if you understand what they mean, right? One of the things I'll point out, you can memorize that the y-intercept is 0, comma c based on the standard form. But at the end of the day, what do you know about every y-intercept that has ever existed?
It has an x value of 0.
It has an x value of 0. And so you can always substitute 0 in for x and figure out what the y is. In a similar way for the x-intercepts, what do you know about every x-intercept that has ever existed?
It has a y value.
The y value is 0. And that should help us keep it straight and be careful that the x-intercepts are R1, comma 0 because the y value is 0. And R2, comma 0 because again the y value is 0. You can memorize all of those points, but it's going to be easier if you understand why they are the way they are. There's a lot of algebra that you can memorize. It has a lot to memorize. Understanding and applying is much more important. Okay, so here's where we are with B. So let's see what we said about these different equations. We said, stop poll. Okay, 19 of us agreed that f1 of x could match this graph. So what are we seeing in f1 that tells us it can match that graph? What's making a... So first off, let's pause for 1 second because I do want to emphasize this. The first piece of evidence that you should identify is not even concavity. It's the what? It's the equation. Like what equation are we looking at in f1 of x?
Vertex.
That's vertex form. That identifying that as vertex form is going to make it easier to identify, one, what I can see there, and two, what's happening. So I heard a lot of us say concave up. What's telling us that this parabola is concave up, Madison?
A is greater than 0.
A is greater than 0, right? A is equal to 2 is greater than 0, concave up. Does that match the graph?
Yeah.
Okay. What else should we see from that vertex form?
B.
The vertex, right? It's vertex form. What would the vertex be?
75, comma, negative 90.
Right, so h comma k, so it's a positive 75, comma, negative 92. So is this to the right and down?
Yeah.
Yeah. Again, the scaling doesn't matter, it just matters is it positive or negative. So does f1 of x work?
Yeah.
Okay. Alright, I saw some people, I think, say f2. Only a handful though, so most of us are thinking not f2. Can anyone give me an argument for why it's not f2? The majority of us thought not f2. Yes, Gabby?
Because one of the x integers are negative x-intercepts.
X-intercepts. Okay, so this. So first off, you're referring to the x-intercepts because we have what form here? Factored form, right? We want to recognize that it's factored form. And by the way, this is really strong evidence. What I'm about to show is not as strong, but it might be a 3 or a 3+ on an understanding check. But we have factored form. Now, does the concavity match? Yes. This first root, or first x-intercept would be 8, comma, 0. That could work. But what's the second one? Is that convincing evidence, right, that this one does not work? Yeah. We don't have an x-intercept in that graph. Notice we need to identify that form first. A lot of us thought F3, but not as many as those of us for F1. So for someone, I will say over half said F3, so can someone who said F3 give us evidence? Hudson?
It's concave up.
Okay, how do you know that?
Because 8 is greater than 0 and 8 equals to A.
So 8 is A is greater than 0. How do you know that that's A though?
Because the equation is ax squared plus bx equals 2.
Okay, so can anyone add on to that a little bit to give us a little bit more detail about what he's referring to there? Oh yeah, we're looking at that standard form, right? We want to recognize that we are referring to standard form here. And so, yeah, we see our A. Okay, concave up, that works. What else do we see?
The y-intercept's positive.
How do we know this y-intercept? Oh, yeah, because it's
That's standard.
standard form, right? Specifically, the y-intercept would be 0, comma, to 40. And we don't see it, but is this going to continue going up
Yeah.
and eventually intersect that y-axis at a positive value?
Yes.
Madison?
Alright, looking at the graph,
Yeah.
you pointed to the graph, and you were like, you can tell here that there's no x-intercept. How can you tell that?
What?
No, never mind.
Did I say that?
Yeah, you did say that.
There's no x-intercept?
You meant the x-intercept wasn't positive, but you ended up saying that there was no x-intercept.
There was, I know, I said there's no negative x-intercept.
Oh,
I got you now. I said there's no negative x-intercept because I was intentional about that and I do remember that detail. But notice these are both to the right, so they're both positive. You're referring to F2 though, right? Yeah. So good question, but yeah, there was no negative was the issue. All right, so does F3 work?
No. I mean, my bad. Yeah.
It's concave up, does that have a positive y-intercept?
Yeah.
Yes. All right, F4.
Concave down.
Yeah, we have this, what form are we looking at?
Factor.
Factored form. And so we see right away that A is -3, which is less than 0, concave down. That does not work. Would the x-intercepts work for F4?
Yeah.
Yeah.
Yeah, notice both x-intercepts would be positive, that matches, but the concavity would be the issue there. What's up?
What was that equation from? The ax squared plus bx plus c.
Standard form. Yeah, that's standard form.
So if it's concave down, you don't even go look at
You can. Now, I will say this, like, this would probably be a 4. What do you think I would want to see to make it a 4 plus that extra level of, like, true mastery of this?
Wait, which one are you talking about?
F4.
It's negative. The A is negative.
I'll say this is all you would need to say here.
From that, what you wrote?
So far, right? But there's another step, like, to go to that 4 plus. Remember that 4 plus is that, like, super clear, convincing, and consistent
Talking about
evidence.
when you do your roots and you.
Like,
find
it's
your
still
average.
factored form, right?
Yeah.
Could you still identify what the roots are? And note, hey, the roots, or the x-intercepts work, but the concavity doesn't. Right, so this as is might be a 4, but that super clear understanding or mastery would be, hey, the x-intercepts do work, here's the x-intercepts, but still the concavity doesn't work. That's what goes from a 4 to a 4 plus. Okay? So, all right, what about F5?
Concave down.
Concave down, we're looking at what form?
Vertex.
That's that vertex form. Right?
Factored form, because the parentheses are squared.
I thought factored form was this where we had 2 sets of parentheses.
Yeah, but the parentheses are squared, which makes it 2 parentheses, doesn't it? On 5?
On 5?
Yeah. You just said it wasn't vertex.
I-
I thought you said it wasn't vertex.
No, a times x minus h squared plus k.
I thought you
This
said-
plus k at the end is what makes it vertex. You get that, Dustin?
I thought you just said it wasn't. That's
No,
all.
no. It is vertex. Alright, F6. What form?
Vertex. Oh, my bad. We on 6, right?
Yeah, 6.
We on
Standard.
form. Yeah.
Concavity is
Up.
up, that works, but the y-intercept is
Yeah.
negative. Notice the y-intercept to be 0, -2. That does not work.
You said it's standard?
Yeah. Yeah. Notice if it's x squared plus 6x minus 2, that matches ax squared plus bx plus c. Right? Okay. F7,
Vertex form.
that's vertex form.
Concave up.
Yeah, concave up, that works.
Y-intercept's negative. Wait, never.
Do we have a y-intercept there?
No.
See, this is why we need to identify the form. Like, if we identify this as vertex form, we should know we're not looking at a y-intercept. Where's the only time that we easily and quickly see the y-intercept?
Factor form.
Standard form. Remember, factored form is not the y-intercept, it is the x-intercept. And see, this is why we need to study those equations and really know those differences. But we have vertex form here. and that vertex be -4, -2. That does not match the graph, so that one's out. What form do we have in F8? Factored form, so what are we going to look at?
X-intercept.
X-intercepts.
They negative.
They would both be negative. Remember, it's x minus r1, so we need to identify the opposite.
So that would,
It wouldn't work.
Would not work. Now, again, I will point out, can I find the y-intercepts pretty easily for F8? How would I find the y-intercepts for F8 of x?
Substitute.
Right. If I am looking at the y-intercept, what do I know about every y-intercept that's ever existed?
Has an x value of 0.
Has an x value of 0. So what would the y-intercept be?
6.
1, please.
1 times
1 times 1
is 1.
times,
3.
3.
Is there?
so it's just 3.
Close enough.
We good on that? Master, you give me a look like Mr. Kenny, I'm not good
I'm
with
all
that.
good, bro.
Huh?
I'm all good.
Okay. Again, just simplify inside the parentheses. Okay, so notice, could the y-intercept match there?
Yes.
Yeah, y-intercept could match. I do have factored form, and I will say this, you don't have to go to this level, but you'll want to do this for other stuff. Can I find the vertex for F8 of x?
Yeah.
Yeah.
What would I need to do to find the vertex? Opposite of b divided by 2a. Which form is that for, though?
Standard.
Remember, standard form is where we have a and b. This is factored form. Where's the vertex
Wait,
in
no, you have to
respect?
add your roots to the bottom of my finger.
What are you doing with that? I almost gave it away. You're averaging those roots, right? Remember, the vertex is in the middle of our
Wait,
roots,
so I was right.
so we would average those roots. So for the vertex, -1 plus -3 divided by 2, that would just be -2. Notice there's the x value of the vertex. And so this is again why we have to keep those ideas straight. You can memorize R1 plus R2 divided by 2, but it's going to be easier to say, hey, my vertex is in the middle of the roots. So I just average them. Okay? Now that's only the x value of the vertex. What do I need to do to find the y value? Substitute it in. Right? So we wrote out algebraically this idea yesterday, and you can memorize this. I don't recommend it, because really all I'm saying is I'm going to average my roots and then substitute that in. So F8 of -2 would be 1 times -2 plus 1 times -2 plus 3 equals 1 times -1 times 1 is equal to?
One.
Negative 1.
Positive times negative times positive.
I was just looking at,
Okay?
yeah.
So notice what's the vertex then?
Concave down.
That's concavity. What's the
That-
vertex?
Is it -2 from a -1?
There's my x, there's my y. That's it. And you can check it, right? So this isn't what we're focusing on right now, but I do want you to note that you can check as you're doing practice problems. That's not what I wanted. What was the equation? X plus 1 times x plus 3?
Yeah.
Does that have a vertex of -2, -1?
Yeah.
Ooh, that's hard to see.
It is.
-2, -1? Yep. Does it have a y-intercept of 0, 3? So notice all these things can be seen quickly on the graph. Practice doing them just off the equation first, and then during practice graph them to check yourself. Because I will be expecting to see that algebraic work on the test. Even if it's on a calculator portion of the test, I will expect to see that algebraic work for you to score above a 1+. Okay? Alright, let's do one last set of these before we end the lesson. Let's do 1C here. Let's try to get this done in the next couple minutes. So look at those 6 equations. Identify which of those 6 could go with this graph. Okay, so 1C, identify which of those equations could go with that graph there. It takes a little bit of time, but we can get there.
This is.
Now, make sure we check in with each other. I shouldn't have said good. Talk with each other first. Paige, you already finished all yours?
Oh, no, sorry, I drew on my paper. I didn't think you were gonna do it the opposite.
Why did you not think we would do
Right, like a preschooler. Get the teeth off. You don't like the white teeth.
I don't.
Can I do it after this, Mr. Kenny?
That's one complicated, right?
I got a question.
Hold up.
Do the opposite. I made some vertex ones, do the opposite of parentheses, right? So that's negative 6. Vertex, right?
Girl, I don't.
No, those have to be
that. Be real.
For a factor, it's different.
Here, we're not,
That's
we're
not-
not, make sure
You
you
do
don't.
the opposite.
That
That's what's on parentheses.
was standard.
But what about vertex?
They don't even touch you.
After is the one with the, it's the root.
F of 2. I just told you, Kate. It's 2 negative.
If the line or parabola
Wait,
doesn't touch the
where's that?
x shape, it's not gonna have any extensions, right?
So,
So
and Mr.
factor
Kenny,
form doesn't work at all.
this one doesn't have any extra, so you can't use factor formulas.
Fantastic.
The first one not going, right?
I'm too smart, look at
Right? Factor form deals with the roots of the x-intercept.
Go back.
At least, I will say this, you don't know how to do it yet, but there are no x-intercepts on that. We'll learn a little bit more. So which one will work? Sorry. You haven't identified that, you just identified some features. When you look more at those, figure it out. Okay, so keep working on it.
You just, I
I
just
want
asked
to
you.
make sure I'm right about this theory.
What's your theory?
So you know how factors form, right?
Yeah.
It's based off of x-intercept. This line for parabola, we don't have it. So the factor doesn't work.
What do y'all think? That makes sense.
I don't know, that's pretty good for me.
We're gonna learn a little bit more about a way to make factor form work, but that's not gonna be for a couple lessons. There's something called imaginary numbers that we'll learn about. Hold on 1 second, he has his hand up now.
Can you just talk to me about the factor form thing, where there's like no x-intercepts?
Don't
So
think
like,
that would
just
be
like x at all, is it?
Right?
Isn't 8
Factor form deals with x-intercepts.
K is y?
We don't have x-intercepts.
Sorry, I just popped a finger.
What's up, Salita?
Okay,
I don't
so
think
if
it's.
either one of these are negative, like how it was on the test towards to the right, would it be?
You could, but like when I'm looking at this one, right? You're talking about x-intercepts, right? What are the x-intercepts for graph C?
1, 5, looks right. No, there's something positive. For F.
So if we have x-intercepts, could that work?
Okay, but, so if either,
Not
so
in
if the
this
y
case,
is
because it's
negative,
negative.
now we're since.
And if it was
So
negative.
language barring, you
Like if
know
the
it's
y,
about
like if the
vertex.
one's negative,
Right, because that vertex goes up. Also, the vertex is to the right and up. For F2, the vertex is to the left hand.
But what is,
Negative 6, negative 5, to the left and down.
oh, I thought you come out.
I didn't say the concavity, I said the vertex.
what is the 400? Is that like A?
No, Boyer, how's it going?
Wait,
Have you talked to the group at all about it?
To find out if it matches me.
I am more than happy to help you, but I need y'all to talk with each other first. Y'all need, no, Boyer's asking questions, I need y'all to answer them. What he's trying to look over is looking at the paper and not asking questions.
Wouldn't F5
All you're doing is this point right here, this point right here.
Nobody likes cooperate.
This being your x, this being your y.
That's not true for this group, I've seen most people in this group
No, but you
cooperate.
square it. So
Should be though. You need to be like on double
But that's not true with this group, so you're projecting your problems on other times.
So you just group A is solved and work with it. No, that was not it. Vertex, you the what's it called?
Oh, yeah. I wrote negative and erased it. That's all I said. Shut up, man.
Thank you, thank you, thank you. So I heard a theory from a couple of students pretty early on. Owen, can you give us your theory?
My theory was that on factored form, that it's based off of x-intercepts for R1 and R2, but on this parabola, there are no x-intercepts. So I said that both the factored form would not work.
Anybody want to add on to or push back on that theory?
Yeah, he's right.
I was like, yeah, he's right. Anybody else want to add on to or push back on?
It doesn't have X in it.
Anybody want me to reword?
Like it doesn't go to X.
Okay, so we're looking at the idea that this is factored form, which we connect to x-intercepts, and I need you to hear me very clearly on this. We can't do factored form yet for a graph like C. There are no x-intercepts. There are still roots. Roots are based on the equation, and because it's quadratic, right, x squared is always going to have two roots. That just means we actually need to learn about a new number system, and we'll talk about that in 2 lessons. And so yeah, but at least for now, there's no x-intercepts. So F1 and F4 will not work.
I got them.
You got that?
I did, I changed it too.
Say it again.
I did.
You didn't get what? Like you thought those worked for that graph?
I thought the first one worked, but
Okay, but what?
I seen even though X, I mean X, yeah, but I still
Right.
didn't.
So we have factored form. We would want to identify that. We have those x-intercepts. Do we have x-intercepts?
No.
No. So that can't work. All right. Which equations did work?
3.
5 and 3.
Yeah, 3.
3 and 5. Okay. So what eliminated F2?
The vertex was negative.
Yeah, negative
Ooh,
6.
be careful.
Negative
A vertex can't be negative because there's 2 values to it. What was the vertex?
Negative 6, negative 5.
Negative 6, negative 5. And I will say this, what quadrant does that put the vertex in? Not 4.
Unless
3.
second.
Ain't that 3 or 4?
That's 3. We start here and we go counterclockwise. That's quadrant 3. Is that where the vertex is for that graph?
No.
No. So the vertex does not match. It's in the wrong quadrant. Okay. When I look at F3, that's what form?
Standard.
That's standard form. AX squared plus BX plus C. So I should see that y-intercept is 0, 10,000 and 10. Could that work?
Yeah.
It's a positive value for the y-intercept. The scale is super off, but that could work. Does the concavity match?
Yeah.
Yep. Okay. So there we go. And Jackson, I think I saw you earlier also doing the x equals negative b divided by 2a. Is that right? Looking at that vertex. And we would want to notice, right, the opposite of b, it's already negative 400, so that'd be a positive 400. Divided by 2 times 4, 400 divided by 8 is 50. Now, to get the y value, I would definitely have to use a calculator. But is that vertex at least to the right to match that 50?
Yeah.
Yeah, okay. So all those things are coming together. What about F6?
Yeah, it can work. The vertex is 6,5.
No, F6. Oh, we haven't done F5, you're right. The vertex would be 6, 5. So to the right 6,
And
up 5,
It's concave up too.
and it's concave up. So to the right and up. Yes, Tori?
Oh, I didn't have anything.
Oh, okay. You just had your, yeah. That's fair. F6,
It can't work.
it does not work. It's a positive 1 for A, so it is concave up, but
It's a negative y-intercept.
negative y-intercept. Even if that wasn't there, if we looked at the vertex, right, negative b divided by 2a, the opposite of 2 is negative 2, divided by 2 times the a of 1 gives me negative 1. So notice for that vertex, it would be to the left. Is my vertex to the left? No. So notice all those different features are coming together. We want to pay attention to those things. What are your questions before we continue?
Are we gonna do practice?
Yes.
I mean, I'm getting it.
It won't be in this form, but yes, you'll have more practice today. About to.
Oh, right there. At the bottom.
So, consider the two functions shown from question 1. So these were given. Identify the form of the function given and then write the function in the other two forms if possible.
Vector and vertex.
Okay, so factored form. And vertex form. So, if I want the other two forms, I want vertex form and I want standard form, right? This is going to apply for the next lesson that we do, so I'm going to do a little bit more direct instruction than normal. But if I want standard form, I want ax squared plus bx plus c. Anybody know what I could do to get this into standard form?
Couldn't you do what it says in what we do two and then where parentheses x plus one, can you convert that into ax squared?
Well, but that wouldn't be ax squared. How would I take that -2 and make that x squared? Notice that's -2 times x, not x times x. Good thought though. We can distribute. I need you to hear me very clearly on this. If you're ever trying to go to standard form, that first step is to distribute. Whether you're in factored form or in vertex form, your first step is to distribute. So, to go to standard form, distribute.
How do you distribute?
We're going to talk about it. Don't you dare say that word in my class.
What word?
Foil. I'll explain why in
She
a
said
second.
it. I promise you she did.
I understand they may have, but foiling only works in this case, and I want you to learn good practices. So let's break down. If you think of that word foil, when we say foil, what does that F stand for? So that's this x times this x. So x times x. The O is what?
Outside.
Wait, so that just means I took x and I multiplied it by x, and I took x and I multiplied it by the 4?
Yeah.
So I distributed the x.
You. I don't know.
Not you, nothing.
I don't know.
So why we can't use foil?
Alright.
Miss Esther used foil.
Well, that ain't me.
That's what I just said. She said it like 2-3 times when she was here.
She be explaining.
That ain't me.
She be explaining.
I don't know her
This
name
kid is so
either.
funny, boy.
This is why we don't use foil. This right here is why we don't use foil, because you can't just do first, outside, inside, last. If I do first, it'd be x times x squared, which is x cubed. Okay? Then x times 1, because that's the outside. And inside would be 2 times x squared. And last would be 2 times 1. What's the issue?
You did it right here with 3x.
I ignored the negative 3x. So instead of FOIL, we distribute. I take this x and I multiply it by x squared. And I take that x and I multiply it by negative 3x. And I take that x and I multiply it by 1. I distribute that x to everything there. And you can get upset about it, but I promise you, there's a reason why I don't want you foiling, and it's because it will not help you long term. You can memorize 1,000 different strategies, or you can just understand that I'm distributing and that's it. And I know you've distributed. If you had just x times x plus 4, you can distribute that, right? Okay, this is no different. Yes, ma'am?
Are we writing this down?
Well, I would have written this down and we're going to work through this. Don't FOIL though, just distribute, right? That first is x times x. The outside is x times 4. That's F and O. 1, or inside, is 1 times x. Last is 1 times 4. Isn't that again just distributing?
So we not doing that.
Huh?
We not doing that.
This?
Yeah.
Not yet. But the idea of distribution will allow us to do that in the next unit or two when we do study that. Okay? So I need y'all to understand, some math teacher, however many years ago, even before I took algebra, for some reason came up with this acronym of FOIL, but it only works in one situation in math. Whereas if you learn how to distribute, that will always work. And I know you've distributed in the past, so use that skill that you've already developed. Don't FOIL. I won't go as far as some math teachers I've heard in the past say, ooh, that's the F word in my class, that's a little ridiculous. But don't FOIL. It's distributing. So, x times x.
X squared.
Okay. And do note I still need the negative 2 outside. X times x is x squared. X times 4.
4 times x.
So 4x. 1 times x.
X.
That's plus x. And 1 times 4. Now I'm going to simplify any like terms. 4x plus 1x.
5x.
Notice how that's super close to standard form now? What's the last step?
Do it outside parentheses, multiply, but what's inside parentheses?
So I need to use what property?
I don't.
Distribution, distributive property. Well, that definitely isn't FOIL. And again, we don't want to use FOIL because that's definitely not
I
it.
don't even know what FOIL is.
Then good. Negative 2x squared minus 10x minus 8.
I'm like, put it squared.
Is that the standard form?
Sure.
I mean, is that standard form?
It looks like it.
It looks like standard form, right? How could I check to make sure that that standard form matches the factored form I started with?
Reversing.
No.
Oh,
No. Good thoughts, but not quite.
Work through them both.
Graph
Get
it.
the same answer.
What do you mean graph it? Like if I graph it, what should I see?
It's the same for my.
I mean, they're supposed to be the same function, right? They look different, but they're still the same, meaning there's an E word for that. They are
Equivalent.
equivalent, right? So if I check that, if I graph those two, all right, so what was the first one we started with? Negative 2 times x plus 1. X plus 1 times x plus 4. There it is. And now we just did negative 2x squared. Was it minus 10x? Minus 8?
Oh, yeah, I'm right.
So are those equivalent? Indeed they are. Right? They mapped right on top of each other. That's the mathematical term that they map to each other, meaning every input has the same output. Okay? So I'm going to, for the sake of space, I'm going to move A over to here for the vertex form. So A is coming over here to vertex form. So what do I need for vertex form?
Oh, you need
No space.
X and Y.
vertex.
I need the vertex, the x and y values of the vertex, right?
Yeah.
How would I find the x value of the vertex based on the factored form?
You substitute.
After I substitute after something. I got to average the roots. Remember how the x value of the vertex is the average of the roots? Right.
You add them up.
Remember, the x value of vertex is average of roots. And so, x equals negative 1 plus negative 4 divided by 2. That's negative 5 divided by 2. Which you can leave it like that, or we have calculators, negative 5 divided by 2. Negative 2.5. Now that's only the x value of the vertex. I still need the y value. How would I find that?
Substitute.
Substitute that in. So f of negative 2.5, there's my x. Negative 2.5 plus 1 times negative 2.5 plus 4. Are there any questions about how I'm substituting that in? Because I know it's algebra 2, so I just made assumptions, and that's my bad. So I'm substituting in for x, right? Does anybody else have any questions before I continue?
-1 plus, is that 9 or 4?
Negative 4.
-4.
Because remember, it's based on these roots right here.
Isn't that, is that the, oh, how's it go, is a squared on the bottom, or is that, what is that?
What you're thinking about is negative b
Yeah, I'm thinking-
divided by 2a. That's from standard
That's
form.
something, so what's that?
This is the average of the roots. So remember, if you have factored form, so what we're looking at is roots here at -1 and -4.
Yeah.
Isn't that vertex right in the middle? So if you have the roots, you average the roots to get the x value of the vertex. So I'm averaging the roots to get the x value of the vertex. And now I need the output. Can someone find this out in their calculator? Might be 4.5. Got 20 students in class. I see a handful using their calculators.
Huh? What? Yeah.
Why do you have an extra negative 2.5?
Yeah.
Negative 2
Somebody said,
times negative 2.5 plus 1. Remember, it's negative 2 times x plus 1 times x plus 4. It's just where there's x values that I substitute that negative 2.5 in. So Mayan, what'd you say?
4.5, that's what he.
4.5? Can I get confirmation from somebody?
Yeah.
Max,
Yeah.
Malaysia, Hudson. Okay, so 4.5. So notice that's my vertex. Now I can write vertex form. Again, I would always write out my vertex form first. What is vertex form?
If
A.
x equals a, x,
X minus H.
something k.
And plus
squared. Plus k.
And so what is A?
Concavity.
Well, A defines the concavity, but A is not the concavity.
H is 2.
Not 2.
-2.
Thank you. Remember, if I look over at factored form, A is always A, isn't it? Yikes.
My bad, I was looking at the other one.
Right, A is -2. X minus, what is H? -2.5. So if I'm subtracting a negative, I'm just going to end up adding. Remember how it's always the opposite. Squared
Plus 4.5.
plus 4.5. That is the vertex form for part A. How could I check it?
Do the same thing you did earlier with calculator.
Meaning I what?
Graph it. You
See if
map
it's
it.
equivalent by graphing. Did that also map on top?
That's a big four.
So does that vertex form work?
Yep.
So I want you to notice, like, this is how we would convert among these, and we want this skill for the next part of the lesson, which is going to help develop these things a little bit more clearly. So when I look at part B, I want to point this out right away. We should recognize what kind of parabola we're looking at in B. So when I look at B, what should I recognize about it right away?
Okay.
Concave up. What else?
Y-intercept of 5.
Y'all agree? Y-intercept of 5, or something anyone want to add on to, push back?
Wait, vertex, it has a y-intercept, does it? Or is that standard form?
I mean, it does have a y-intercept, but it's which form here? Vertex form. So does vertex form show us the y-intercept right away?
No.
No.
Doesn't have a vertex
It's vertex. So it has a
of vertex.
vertex of what?
6 and 5.
Comma 5. Be careful, Hudson. That is a common mistake I saw a lot of students make last year, that we don't know or we forget, yes, that's the y value of the vertex, but it's not the y-intercept, right? That's the y value of the vertex. So I want you to think about it. It's to the right 6, and it's up 5. Is there any form, and it's concave up, is there any form that I will not be able to write?
We just talked about it.
Factor form because there's no x-intercept.
There's no x-intercepts, right? So can I do factored form for this one? No. See, this is why we want to be able to look at that equation and recognize those features. So you got to know the equations so that you can recognize the features and quickly say, ah, there's no x-intercepts. No x-intercepts, no factored form, at least yet.
Just a little breezy.
I know, I love it.
Oh.
You know what you should do is you should complain about it some more. I'll totally change the temperature.
It's a little breezy. It's
It's okay.
It's called sarcasm. I will not be changing the temperature. All right. So what form do we want to try to get still? Standard. How are we going to start with standard?
Equation.
Like we did last time?
We're going to what?
Distribute?
We would want to recognize that we would distribute. Now listen carefully. Hey, listen. A lot of students do not pay attention how to properly distribute when we have vertex form. So you need to pay attention to this. Golly. Y'all killing me.
Murder.
I don't care about your calculators, Miss Keenan. I'm going to break all of them. All right. Now, you need to be careful. You have to follow the order of operations. What is the first operation that we need to apply? Okay, but inside the parentheses, can I do anything?
No.
No, so I need to go to the
Exponent.
exponent. What does it mean to square something? You need to write this out.
Multiply it by itself.
Repetitive addition.
Not repetitive addition, repeated
Repetitive
multiplication.
Multiplication.
I knew that.
Listen very carefully. Do not write this down, but pay attention. The most common mistake that students make when they see this is they write x squared minus 36. That is wrong. Yeah, 6 squared is 36. Most students try to write this, but that's because they forget that x minus 6 squared is x minus 6 times x minus 6, so I have to distribute x times x,
X squared.
x squared. Note how I'm keeping my 2 outside the parentheses because I'm not distributing that yet. I'm just distributing the 2 parentheses. So x times x, now that x times negative 6 is
Negative 6x.
negative 6x. I'm done distributing x. I now need to distribute negative 6.
Negative 6.
So I get negative 6x,
Negative. Oh, well. 36?
positive 36. Negative times a negative is positive, okay? Notice again, all I'm doing is distributing, but everything else is staying there because I haven't taken care of it yet. But note, this is the equivalent form of x minus 6 squared. Very different from x squared minus 36, right? So make sure that if you're simple or you're rewriting it, that you write out the x minus 6 times the x minus 6 so that you remember to distribute. Now I distribute my 2x squared minus 24x plus 72. Now I have like terms again. 2x squared minus 24x plus 77. I'm going to go ahead and tell you, I think this is right. How can I check?
Calculator.
How?
I got one on your calculator.
So remember, to check, we want to graph these.
Brain fart.
Okay, so I've got, what was the first one that we started with? They had 2 times x minus 6 squared, was it plus 5?
You forgot to put the 6.
Yeah, you just put X mark.
Thank you. So there's the parabola that we're starting with, and then we got 2x squared minus 24x plus 77. Woohoo! Okay. So this is how we check ourselves.
We should work.
Say again. Celebrate the fact that we got this right.
Right.
Okay, so we're going to apply these ideas within the next lesson, or the next activity in this lesson. Okay? Yes, ma'am.
Is this on the understanding chain?
No.
Good.
What?
Okay. All right. So we're moving to the next activity. Activity 4.3, it'll be one page over. And here's what we're focusing on in activity 4.3. It ties into what we just did of this idea of writing the equation of a quadratic function based on key features given. So if you're going to be given features, how do we write the equation? It's going backwards from what we've been doing. So here is a setup. George and Pat each wrote a quadratic equation with a vertex of 4, 8. Analyze each student's work. Describe the similarities and differences in their equations and determine who is correct. Take just a couple minutes. Figure out who you think is correct, having written the vertex form of a quadratic with that vertex 4, 8. Let's get to talking.
Cool.
So which of those students is correct?
Which students? Georgie.
Stop.
Let's read it.
Are we on the page that has? Stop it.
We're on,
Next page after it.
You wrote that's the page that has.
George. I think George is wrong.
Or just scattered.
I
Anyway.
mean, A's on
Number one.
The next value is, so try to make
What y'all
it
think?
20, right?
George?
Yeah. H is possible.
Why do you think George is right and Pat's wrong?
H is possible.
Just saying things? Yeah, quit saying things.
things.
Say it,
That's
but
my
like have your
independent
evidence. Let's look at it.
You gotta predict.
You gotta read and think before you predict.
What about Georgie?
Have evidence for your claim.
My hand hurts. I think I need a break.
I'm sorry you feel this way.
Negative 1/2.
My brain stopped working.
So that would make,
Thank you. Thank you. So let's just talk about it a little bit. We've got some ideas thinking. Figure this might make it easier to see. So who do you think's right for a quadratic equation with a vertex of 4, 8?
Forehead.
Pat?
Forehead.
So you don't. So George doesn't have an equation with a vertex 4, 8.
He does, but he can't.
They're both
When he
right.
said,
They're both right. They're both right.
They both got it. They were just, it's the very last problem is Tony.
But
Oh, George was wrong.
why is he wrong? Does he have a vertex of 4, 8?
Yes, he does, but he's wrong because he got a negative half up in there.
How do you know that that's wrong?
Right, they don't got it wrong, they control kind of.
But y'all are ignoring my question. Does George have a vertex of 4, 8?
Yes.
So does he have an equation
Yes.
with that vertex?
They both have the
Oh, they're both right.
Exactly.
Now, listen very carefully. Hey, listen. Y'all are asking, how in the world did he get A? Well, in order to get the proper equation for one parabola, you have to have another point. But do they both have a vertex 4, 8?
Yeah.
Yes. And so this is what we would want to note here and make sense of. They're both right. So they are both right.
You want to write this right?
Yes, dude.
Yes. For the constraints. What's the what about? Constraints? Anybody know what I mean by constraints?
I like what they're asking.
Kind of. By the requirements.
That's what I was gonna say.
The constraints are the requirements of the problem. The only requirement was that they have a quadratic equation with that vertex. They have that. So they're good to go on that side of things. But we do need to learn, okay, so how would I get A? And I will say this, to have a specific A, you need another what?
Oh.
Point. Right? To get a specific A, to get one parabola, we would need another point. So here's what we're going to look at. So here's an example that is in the books. Notice this is a worked example. So you can come back to this later. Write the quadratic function given the vertex 5, 2, and now we have a point 4, 9. Okay, if I have a vertex, which equation am I going to use? The vertex form, right? And now look at the information given. The vertex at 5. What value is 5?
B, right?
It's the X value.
It's the X value of the vertex, but what letter do we use for that?
H.
Okay, so 5 is my H.
2 is the K.
2 is my K. So what would the 4 and the 9 be?
X and Y.
Oh, that's X and that's Y. Or we can use f of x. Notice they substitute the given values into the vertex form of the function. When they did that, how many unknowns were they left with? They're left with a, one unknown. So they got 9 is equal to a times 4 minus 5 squared plus 2. If I have one unknown, what do I need to do to that equation? I now need to solve for a. That's all it is. If I am given a second point, I'm going to substitute my values in that I know, and I'm going to then solve for a. And so we get 9, I'm going to work it out here, equals a times 4 minus 5 is?
1.
Not 1.
Negative 1.
Negative 1.
Wait, why is it negative?
4 minus 5.
Oh, I'm sorry.
Right? So negative 1 squared plus 2. So, okay, that's okay. We make mistakes. We just got to learn from it. Okay? We are so used to, and I need y'all to hear me very clearly on this. So many of us are just used to speed is what shows how intelligent we are. It doesn't matter how fast you are. Slow down and think through it. It's much more important to understand. So slow it down and make sure you think through it. But 4 minus 5 is negative 1. And then, and so what's the next thing I want to do?
Wait, we're going to right?
So I want to point this out. One thing that a lot of students miss, when solving, the first step is actually to simplify. Notice I'm simplifying everything first, then I'm going to use my inverses to solve. But negative 1 squared, remember that's negative 1 times negative 1.
I meant positive.
It's a positive, right? Now what can I do to solve that equation?
Subtract 2.
Divide, then.
Subtract 2 by 9.
So, hey, here's a thing to help you. One thing I'll point out, well, two things I'll point out. One, the order to solve is actually the inverse of the order of operations. So the order of operations, remember, is to simplify. Right? Those are at the same time, those are at the same time.
So we
But
subtract first.
the order of operations to solve is the inverse, taking care of addition and subtraction first. Because here's the thing, I want that A, right? So I need to peel away the things that are furthest from the A first. So minus 2, minus 2. Because what's 2 minus 2?
0.
Not nothing, like, I mean, it is nothing, but A's that number, it is 0, okay? And I want to point that out, I can't remember if I mentioned this in this class yet, but notice I subtracted 2 because I wanted to make a 0, but whatever I do to one side of the equation, I gotta do to the other, right? That's the idea, I'm not moving anything, I'm creating a 0 and using a property of equality. Now, 9 minus 2 is 7. But also, what's A times 1? A. So I don't need to divide by anything. A is 7. I substitute that 7 in for A, and now I have my equation. Right? It's okay. So the A is 7, and I have my H and K, so there's my equation. That's it.
Oh, I see what you did. You got both of these, that's right.
Yeah, you don't need to. It's just A times 1, so okay.
I don't usually write no one, I just.
Okay. Hey, I'm going to come collect whatever that is from y'all in group 7 if you can't pay attention.
You're tripping so
So, here's a second worked example. Notice it's in the book already.
Like you, she jumped right there. She took my seat.
Please notice in the second worked example it says write a quadratic function given these roots. And we have a point. Well, we have 3 points because we're not given a vertex this time, we're given the x value of the x-intercept. I'm given roots, so I'm going to use the factored form, right? We would want to recognize, and I will point out, if you have roots, you have to have both roots and a third point. Because if I were to do R1 and R2, so So if I only do those, I have f of x equals a